Okay, in this video, we're going to look at section 6.4, where we're going to talk about radians, arc length, and angular speed. When we looked at degrees on a circle, we had our axes, and we had a circle going all the way around. And we spent some time looking at the degree measures that we have going around this circle. We started at 0, we went 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so far and so forth all around the circle. Now there is a different way that we can measure the angle of that we can form on this circle, and that's using what's called a radian measure. And radian measure comes from the fact that we give a radius and we have the circumference of a circle is equal to 2 pi times the radius of a circle. So if we take r here as our radius and we decide that we're going to take this length of r and we're going to lay it right on the outside here, it ends up being about 57 degrees. And so we have one radius length, like if this was a piece of string and we laid it on the outside here, this would also be a length of r as well. We call this angle 1 radian. And there's radians as we go all the way around the circle. There's 2 radians, there's 3 radians. If we add 0.14-ish, then we have 3.14 radians, which we all know is equal to pi. If we go 2 times around the circle, then we're going to get 2 pi. Well, this makes a lot of sense because the circumference of a circle is equal to 2 pi times the radius. Now, the advantage of doing degree angles using radian measure is that it makes some calculations that we have later on a whole heck of a lot easier. But let me show you how these radians stack up in comparison to degrees on a circle. Here we have a picture of our unit circle. And on our unit circle, we start off with 0 degrees, as I had on my diagram over here. And we go to 30 degrees, 45, 60, 90, 120, 150, 180, and all the way around the circle. We can see that we have pi over 6, pi over 4, pi over 3, and these are the radian measures that we're using here. We can see if we go all the way around, we end up with pi radians. We go twice around, we end up with 2 pi radians. And then we have all these little radian increments in between. Now, normally, we would spend a lot of time figuring out how to go from 30 to pi over 6. And probably high school, you did spend a lot of time memorizing all of these radian measures. And the reason why is because it's important to understand these values that go along with it. Remember that we would drop a perpendicular here and we would make a right triangle, and then using our special right triangles we could get these measures for the x value and for the y value. Remember that the x value stands for the cosine of the angle and the y value stands for the sine of the angle. So we have the cosine of theta and we have the sine theta, and that represents every single point that's around this circle. Now again, it's just a different way of measuring our angles as we go all the way around the circle. Now you can have more than 2 pi radians. You can go around twice and have 4 pi. You can have 6 pi, 8 pi. You can even go into the negative direction. If I had negative pi over 3, that'd be an angle that I would have right about here. So it's just a different way of measuring these things. Now to convert, it's actually quite simple. You use this fraction where we have 180 degrees divided by pi, or you do pi over 180 degrees. And what that allows you to do is convert from either degrees to radians or radians to degrees. Now we use this one here if we're going to go to radians to degrees, and this one here we want to use if we want to go from degrees into radians. Now you can remember that because whatever you want to convert to is what you want to have up on top too. And also, if we factor out the labels that we have here, it makes it relatively straightforward as well. For example, let's say we had 30 degrees and we wanted to convert to radians. I'm going to multiply that by pi over 180 degrees. Now here, because I wrote in my degree symbols, I'm going to be able to cancel those out. And I'm also going to reduce this fraction. Now generally we just reduce our fractions. We're going to get 3 over 18. 3 goes into 18 6 times. So that's going to be pi over 6. And this matches what we have in our diagram over here. We have 30 degrees is equal to pi over 6 radians. Now, if you want to convert the other way, straightforward as well. Let's say that we had 5 pi over 3 radians, and we wanted to convert that into degrees. So I'm going to make sure that I multiply by the fraction of 180 degrees, and I would divide that by pi. And I know I'm doing the right thing here because my first order of business is going to be able to cancel pi out. And then it just becomes a math problem. We're going to do 5 times 180, and then I'm going to do that divide by 3. So I'm going to do 5 times 180, and then I divide that by 3. I know you guys can't see that, but let's see if I can. Yeah, not quite, but you're going to get 300 degrees. Okay. And so that's it for pretty much for radian measure. In the next video, we'll talk about arc length.